Assalamu alaikum warahmatullahi wabarakatuh. This is me, Abdurrazzaq Naji Salah Al Jabali. My matric number is ZE190149. So I'm gonna do the presentation for the first part of our group assignment, which is usage of Gauss elimination method and elimination method with bivoting. So in this project, we have successfully choose our problem, which is about electrical circuit system, and we apply the KVL and KCL and solve it through the method, the numerical method of Gauss's elimination method and elimination method with bivoting. So this group was consist of Norman Bonsinni and Muhammad Alif Ayman. So the presentation contents, which is will gonna be about the introduction and the manual calculation and the simulation. So I'm gonna do the first part, which is about the introduction of our problem, which we successfully chosen. So in this project, we would be study to see if Kirchhoff law are corrected through the electrical circuit problem, which is expressed mathematically. So through that circuit or that problem, we have occurred and applied and do the KVL, and KCL for the nodes of the problems and occur the equations and solve the equation by using the Gauss's elimination method or the numerical method, which we choose to answer our assignment. So the fundamental concept that lead to develop and construct implementation of electrical circuit for resistive circuit were designed to investigate KVL and KCL utilization matrix, which can be used to describe numerical method linear system of equation. The two aspects of the method which will be used to solve the issue are the Gauss's elimination method and the Gauss's elimination method with bivoting. So it could be accomplished, and we have successfully calculate the problem or the electrical system which we choose to answer, so by the two numerical method, and also prove that answer by the MATLAB software. So this is our problem or our circuit, which was consist of the four resistors, which is gonna be 1/3 and 1/2, 1/2, and the 1/6. So and two current sources and one voltage sources. So this is circuit or this system circuit or this problem which we successfully choose consists also of three nodes, and these three nodes we successfully occur our equations. Through that equation we have answered our question by using the two ways manual and also proving the ways by the MATLAB software. So the objective of using Gauss's elimination method, can express, is very easy to determine the calculation when you use Gauss's elimination method, and implementation in mathematical expression or equation to compute the voltage current in each node or in each loop and in the electrical system was very easy. So and also observing the calculation result manually or software and compare the answer, and we get the final result the same. This is the process or the flow chart of our project or assignment, which we have successfully go through. So first step was to conduct manual calculation and the software calculation, the software coding. So the software coding and the manual calculation, we get the result and start to compare the third step, comparing the result from the manual calculation and the software, and secondly lastly analyzes the result from the manual calculation and also the MATLAB software. So thank you so much. That's all for me. I will let my another friend to complete the presentation. Thank you.
Assalamualaikum. My name is Muhammad Alif Aiman bin Abdullah. Today I would like to present about manual calculation. For the node 1, V1 minus V2 over 1/2 plus V1 minus V3 over 1/3 equal to 4. 2v1 minus 2v2 plus 3v1 minus 3v3 equal to 4. 5v1 minus 2v2 minus 3v3 equal to 4. That is our equation 1. For the not 2 and not 3, v2 minus v3 equal to 5. This is our equation 2. v2 minus v1 over 1 over 2 plus v2 over 1 over 2 plus v3 minus v1 over 1 over 3 plus v3 over 1 over 6 equal to 9. 2v2 minus 2v1 plus 2v2 plus 3v3 minus 3v1 plus 6v3 equal to 9. Negative 5v1 plus 4v2 plus 9v3 equal to 9. This is our equation 3. So, we get the metric form like this is 5, 0, negative 5, negative 2, 1, 4, negative 3, negative 1, 9, 4, 5, 9. For the Gauss elimination method, this is our original metric form. Step 1, we eliminate S1 from R3. Negative 5 over 5 multiply R1 plus R3. So we get 5, 0, 0, negative 2, 1, 2, negative 3, negative 1, 6, 4, 5, 13. For the step 2, eliminate S2 from R3, negative 2 over 1, R2 plus R3. So metric form we get 5, 0, 0, negative 2, 1, 0, negative 3, negative 1, 8, 4, 5, 3. For the step 2, perform back substitution to solve V. 8 V3 equal to 3. V3 equal to 3 over 8. V2 minus V3 equal to 5. V2 minus 3 over 8 equal to 5. V2 equal 5 plus 3 over 8. V2 equal to 43 over 8. 5V1 minus 2V2 minus 3V3 equal to 4. 5V1 minus 2, 43 over 8. Negative 3, 3 over 8 equal to 4. V1 equal to 4 plus 2, 43 over 8 plus 3, 3 over 8 over 5. So we get V1 equal to 127 over 40. V2 equal to 43 over 8. V3 equal to 3 over 8. We go to another method, Gauss elimination with pivoting method. This is our original metric form. This is step 1. Swap R2 with R3. So 5, negative 5, 0, negative 2, 4, 1, negative 3, 9, negative 1, 4, 9, 5. Step 2. Eliminate S1 from R2. Negative 5 over 5. R1 plus R2. 5, 0, 0. Negative 2, 2, 1. Negative 3, 6. Negative 1, 4, 13, 5. Step 3. We eliminate S2 from R3. Negative 1 over 2. R3 plus R2. So 5, 0, 0. Negative 2, 2, 0. Negative 3, 6. Negative 4, 4, 13. Negative 3 over 2. For the step 4, perform back substitution to solve V. Negative 4 V3 equal to negative 3 over 2. V3 equal to 3 over 8. 2V2 plus 6 V3 equal to 13. 2V2 plus 6 over 3 over 8 equal 13. 2V2 equal to 13 minus 6 3 over 8. V2 equal to 43 over 8. 5V1 minus 2V2 minus 3V3 equal to 4. 5V1 minus 2 multiplied by 43 over 8. Negative 3. 3 over 8 equal to 4. V1 equal to 4 plus 2 multiply 43 over 8 plus 3 multiply 3 over 8 divide by 5. So we get V1 equal to 127 over 40. V2 equal to 43 over 8. V3 equal to 3 over 8. Same with Gauss elimination method. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norman Besenu, DE190173, and today I will show the simulation that we have do for our project using a MATLAB coding. From the previous part of our video, we have shown how to get the manual calculation for Gauss elimination and Gauss elimination with pivoting for the circuit that we have choose for this project. So now I will show the simulation to prove that our manual calculation is correct. After we have obtained the matrix form from our equation previously, we must insert the matrix form inside our MATLAB coding. So in order to insert the matrix form into our MATLAB coding, we must declare the matrix as the row 1, row 2, and row 3, this row. So the info is actually the left hand side of our matrix, while B is the right hand side of our matrix. The first three numbers is the row 1, and the second one is row 2, and this one is for row 3 for our left hand side. And this is the answer for our equation that we have derived in the manual calculation. So this part we declare it as B, and in order to put all the left hand side and the right hand side of the matrix into one form, we must declare it as A, which is info, and B. So they have left hand side and the right hand side of our equation. Now, as we know, Gauss elimination method we use to make sure that we can get these types of triangular matrix, which they will have 0 for this part. So, how to do the Gauss elimination using the MATLAB coding? As we can see here, this one is 0, but at the left one they have a numbers actually. So we must remove this number and make it become a 0 for A21, A31, and also for A32. Now, this is a formula that we use to find the new value for our A21 and A31, also for the rest of the row. Now, from the line 4 from our coding, we use I equal to 1, size A1, and actually the size A, 1 is the number of the row that we have. So we do a looping for these types of, so that all the row can have the Gauss elimination method. So inside the loop for this I, we have another loop of J, and actually J is same as the I, and from the matrix form, we can conclude that okay, for A21, 2 is J and 1 is I, and for A31, 3 is J and 1 is I. So that's why we use J and I, because there is a looping for all of the row for our Gauss elimination method. Now, our formula that we use to find the new value for each A21, and actually we can write A21 as AJ1. Yes. So for this part, so we focus for these two part, we will write this part as A bracket 3 comma semicolon bracket. So because we have so many numbers that we will have A31, A32, and A33, so we use comma semicolon as the number n, so it will increasing. That's why we put here as J equal to I plus 1. So if J is 2, then if I is equal to 1. So if J is 3, so 1 plus 1. So that's why we have here. And for this part, we use this, it is the constant for this equation. So we use key equal to AJI divided by AII. As I mentioned earlier, JI is actually 2, 1, and AII is 811. Same as for A31. How to get the new A31? So for this one, A31 is actually AJ1, AJI, and for A11 is actually the AII. So this is how we get the new, this is the formula that we use to get the new value for each A21 or A31, also for A22 and A33 and so on. So we have done with the loop here. Now this is the full coding for our Gauss elimination method that we use to prove that our simulation is correct. So x is actually the value that we want, that is our solution. So for I equal to size A1, A bracket A comma 1, and this one negative 1 and 1, this is actually the back substitution for our matrix form. So let's say that our back substitution started with the lowest row from our matrix form. That's why we minus 1, because we will do the back substitution. And this one, Hg equal to sum A and so on. This is actually to compute the sum of our elements. And lastly, this one is x bracket I is actually our formula that we use to find our solution. Now then we can put it as solution is x, so it will print our solution for each value of v1, v2 and v3. Now we move to the Gauss elimination with pivoting method. This method is same as Gauss elimination, but the difference is Gauss elimination will swap the row. If for example row 1 is 5 and the bottom one is 10, so we must get the value of the upper row is higher than the lower row. So we will change it. We will swap the row and we will get, so this one, this is the same. Okay, for line 6, this is actually for our pivoting. So we can see here there is a loop here, and we say if A2, for example, if A21 is bigger than A11, so we will change the row, we will swap the row. That's why we use this formula. So the number that are in A21 will move to A11, and from A11 will go down to A21, and it will show the matrix A after we do the pivoting. I will show it later. And now, in order to make the triangular form for our matrix A, which is we want to get the value of 0, 0, 0, like that. That's why we use this formula. This formula is same as the Gauss elimination formula, also for this part. And the only difference is here. Only this part that have some differences for our method. Alright. Now, I will show the simulation for our project. Okay, I have copied the coding inside the MATLAB. So we can see here that all the coding is same as the one that I have shown earlier. So we run and advance our project. So we will get the value of x for v1, v2 and v3. And if we put A here, we will get the matrix form of our equation after we do the Gauss elimination method. So we move to the Gauss elimination with pivoting method. We have declared all the important things and we have insert a loop here, and this is for pivoting. After that, this loop is for triangularized form from A. And lastly, this is the answer. This is the coding for the answer. So we run and advance. So we can see here, this is the matrix that we get after we do the pivoting. So you can see here that actually negative 5 is below here, but it have moved to the upper side, to the second row. It from third row, but it go to third row. It from third row and it goes to second row. It will swap the row 1 and row 2 with row 3. After that, we will get the triangles form. this is the form after we do the pivoting. At this part, it will a little bit different from Gauss elimination because we have sort the row, so the value will change. But actually, the final answer will same as the Gauss elimination method. So what I can calculate here is the value of V1 is 3.175 volt and V2 is 5.375 and for V3 is 0.375. So we have shown that our manual calculation and our simulation is same. So we have proved that our objective of this project is verified, and that's all from me. Thank you.